This platform connects drone design, professional training, and real-world simulation in one physics-based workflow. Here is how the complete system works. We begin on a recreation of Taiwan's drone certification course. Ordered three-dimensional checkpoints guide the pilot through the required figure-8 route, while the system tracks progress, aircraft state, and physical response in real time. The goal is not arcade scoring. It is repeatable, structured flight practice. Next, the aircraft editor turns design choices into flight dynamics. Users can import a model, position each motor, and configure rotor direction, thrust, mass, inertia, aerodynamics, and takeoff or landing behavior. These values are sent to the PX4 and Gazebo physics stack, so changing the aircraft changes how it flies. A short return to the Taiwan course confirms the edited airframe under the same controlled training conditions. The map editor provides the same authoring workflow for the training environment. Instructors can place and transform physical obstacles, define ordered checkpoints, choose the aircraft start pose, and set a fixed pilot station or chase camera. Visual layout and collision geometry are saved together, so the authored course is ready for both instruction and simulation. The edited course is then tested as a complete system. The same aircraft model, flight controller, and map configuration are loaded into the simulator. Obstacles are not decorative. Collision is calculated by the physics engine and immediately affects the aircraft. This makes the editor useful for checking clearance, route difficulty, and failure behavior before a trainee enters the exercise. For larger scenarios, the World Map Selector lets an instructor frame a real location directly on the map. Visual data is batched for performance, while collision is controlled separately to prevent thousands of unnecessary physics objects. The selected area is converted into a centered three-dimensional environment with adjustable detail, material styling, lighting, and atmosphere. Finally, the aircraft is flown across two generated real-world locations. Both environments use the same airframe configuration: PX4 controller, input mapping, wind model, telemetry, and safety systems. This demonstrates the core idea of the platform: design an aircraft, build a course, generate a location, and validate the entire training scenario through one consistent physics workflow. From certification practice to custom aircraft and real-world environments, the platform turns every design decision into a flight you can test, measure, and train. Design, train, verify.